In the last couple of lessons, we have been looking at some collection classes that allow you to specify an object type name as part of the class name. These are known as generic classes, or just as generics. By adding the type name as part of the class name, a class is instantly customized for a specific object type. Here is an example of writing a class and specifying a generic type. The class name is declared with a variable type name appended to the end of it. This is the name that you will use throughout the class where you need to specify the type. Here is the declaration of the reference that will contain an address of objects of the correct type. This is a method that accepts an object of the correct type. All it does is store it in the internal reference. And here's a method that returns an object of the correct type to the caller. Look at it this way. Everywhere in the class that you would use the type name, you use the variable that represents the type. When this class name is used, like this, the compiler creates a class with the right type substituted throughout. It's like a last-moment macro expansion and gives you a memory-resident form of the class that works with that type. The new statement then uses the memory-resident class definition to create an object of that class. A lot happens in this one statement. This example creates a version of the class that stores a string, uses the put method to store it, and the get method to return it. This shows the string after it has been stored in the new object and then returned. Then comes the question, what is the superclass of a generic class? There is a superclass, but it's something that had to be added to the language. Let me show you with an example. This class creates two objects of different types from a generic class hash set. One holds strings and the other holds integers. There is a feeling that the two should have the same superclass because they are genetically so much alike, but they have no common superclass in the natural order of things that are Java. The first object has 3 strings added to it. The second has 3 integer objects added to it. Then methods are called to display them. First, a dedicated string method is called to display the strings. Then a dedicated integer method is called to display the integers. Then a generalized method is called to display both kinds. These two methods are basically the same. Each method accepts the type of set that it will use to create the display. An iterator is retrieved and it's used to return all the objects held in the set, and they're all displayed. Now, as you can see, these methods are the same except for the type, so it should be possible to write this method using a superclass, and that's the new part of the language. Specifying the type as a question mark, a wildcard, creates the superclass. This syntax extends the concept of polymorphism to the generics. The method is the same as the other two methods, but this one is capable of displaying the contents of any set object made from the generic hash set class. Here is the output from all the methods. You can use a wildcard reference anywhere that you could use a superclass reference, such as being the target of an assignment statement to store the address of the object. But there is a slight problem with a superclass being defined this way. I mean, it works, but it opens it up to anything. Anything contained by any generic container could use this same definition of a superclass. You can add a restriction that limits the superclass to a specific set of object types, as in this example. This example is very much like the previous one, except that two sets are constructed to hold the extension of the exception class. The first one of the two is for runtime exceptions. The second one specifies a timeout exception. 3 examples of each type of exception is added to the list. And then the same method is called in both cases to display the members of the 2 sets. And here is the method. Here you see the definition of the class in the parameter list for the method. This class is a hash set that is defined to contain any class that is an extension of the exception class. You can see that this is a restriction from the one in the previous example where there was a simple question mark that would accept any type here. This one has added this special extends restriction. The iterator object here, returned from the set, is exactly the same and has the same restriction. It will accept any object as long as it can only hold objects of a class that is an extension of the exception class. And here's the result. There, the same method listed both types of exceptions. In fact, it would list any type of exception. Oh, look, I finally found an example of a hash set that returns the objects in an order different from the one that they were put in. I told you it worked that way.